What's going on? This is SDG Labs. My name is Anastasio Dalde. Let's do some math! Alright, I want to take a look at this one right here, and I want to take a look at where the x-intercepts are. This is x minus 1, x minus 3 squared. This is x minus 1, x minus 3, and this is x minus 1, x minus 3, that quantity cubed. Where are the x-intercepts of this function right here? Well, we can kind of tell that it is a cubic function because there's an x to the first power here. And then if I multiply all this out, I would have to FOIL it, by the way. This would give me an x squared plus blah, 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 blah. When I multiply those together, I'm going to have an x cubed out in the leading front. So this is going to be a cubic function right there. This is going to be a quadratic because this is just x times x, which is x squared. This is going to be a quartic, or to the fourth power degree polynomial. The intercepts, this is really interesting. The intercepts for this one right here is at positive 1 and positive 3. The intercepts of this parabola is positive 1 and positive 3. And the intercepts of this fourth degree polynomial is positive 1 and positive 3. Because you're setting it equal to 0, so it's equal to, you just set each of these terms equal to 0. But what's interesting is the square term and this cubic term. And what I want to take a look at is what happens to it. All right, let me show you what the graph of this thing looks like. At 1 and 3, for g of x, that is, that's a parabola that crosses at 1 and 3. I know it's a happy parabola because x times x, that would be an x squared term, and there's going to be a positive out in front of it. Those negatives aren't going to affect that x squared term. If you don't believe me, just FOIL that out and you'll see. You're going to get something that looks like that. Happy parabola crosses right here. Now, what's interesting about the cubic function is I know that this is going to be a regular cubic function, so it's going to kind of go like that. But what's interesting about it having two of its factors is x equals 3. Is it kind of tells me that it only touches the x-axis at 2 points. Because it's 1 point and the second point right there. So the graph is going to kind of look like this. Now how can I make it go down and then come back up and only touching at that 1 point? Well, I could make it go down and kind of kiss that point right there. And then come back up. So it is technically only touching at 1 point and it's going down. This h of x cubed, I know that that's a fourth power function, so I know it's probably going to look something like this. It's probably going to be some kind of happy parabola like that. Actually, that's not really a parabola, that is a happy polynomial of the fourth power, because a parabola doesn't have this extra bump in the middle. How's that graph going to look? Well, that graph is going to look like this. This one's going to be a little weird. It only touches at 2 points, 1 and 3. But it's got to look something like this. How would I do that? Well, I could do this. I could have it come down this way. And then what I could do is go like this. And you'll say, wait a second, that second bump isn't really there. And I would argue with you and say, actually, it is. It just happens to be so shallow that it kind of just horizontals off and then goes back up. So that's the way that graph looks. Now what I think is really interesting too is, let's take a look at this. This is f of x. This is h of x. If there is a repeated factor, the repeated factor in this one is x squared. And if it's to the square power, I mean not x squared, but x minus 3, 2 times. See, the factors of this is x minus 1, or is x equals to 1, x equals to 3, and x equals to 3. We call that x equals 3 of multiplicity 2. That's what we say. If it's that, then what happens is when it will actually kind of do this weird thing at that 1 point. it won't just cross, it will usually just kind of like kiss it if it is a square power or an even power. See over here, it kind of looks like a parabola in that general vicinity. Whereas over here, notice the x minus 3 of multiplicity 3, it kind of looks like a cubic function in that general vicinity, in the area of where we're talking about this point of interest, this x minus 3, in the area of x equal to 3. It's going to kind of look like a cubic function. I just kind of want you to notice those things. I want you to take a look at it and be like, that's very interesting. I have no idea what he's going to get at or what he's talking about, but yeah, okay, all right, I can hang with that. Shoots, bro. Up out.